All right, so this is the third video. I want you to have watched all three, right? And this is section 4.3, and we call this mixed and entire radicals. Okay, so section 4.3 in the book. And radicals, right? Remember, we're thinking, right? You should be thinking roots. Could be square roots, right? It could be, actually, let's make that smaller. Right, like it's just roots in general, square roots, cube roots, and so forth, right? So different kinds of roots. So we're going to be working with them, and this is definitely going to build on your knowledge of chapter 3, where we found the prime factorization of numbers and would use those to come up with roots, except for we try to always get a perfect cube or a perfect square or anything like that so we could cancel out the roots, and here it won't be the case necessarily. Okay, so if you ever hear of the multiplication property when it comes to radicals, goes as follows. Okay, so all that means is that if you take the root of something and whatever is inside is being multiplied, so this could be more than just two numbers, but let's say there are two values in there. Okay, you could break these apart and say that this is the exact same thing as taking the root of that index. So this could be, right, square root, cube root, fourth root, fifth root, doesn't matter, of the first number, and multiply that by the root of that second number. So that's, in a nutshell, that's the multiplication property of radicals. Okay, and then we're gonna go for some terms. So this is actually not bad, like 4.1 all the way to 4.3. Right, it just reviews, right? We talked about rationals, irrational numbers. You need to be able to differentiate them just by looking at them. And now we're just also, this is just working with numbers, but it gets more complicated later. So that's why it's very important that these three sections, 4.1, 4.2, and 4.3, you have a pretty good grasp on, because we're going to build on that. Okay, we have something called an entire radical, right? And that just means the entire number is under or inside the root. In other words, right? In other words, root of 40, for example, square root of 40. Okay, a mixed radical has a coefficient and it's not going to be 1, because technically all the roots have a coefficient of 1 in front of it. Okay, it has a coefficient not 1 in front of radical. Okay, in other words, it would look something like this: 2 square root of 5. Okay, so I will just make a note here. 2 root 5 implies, or is saying, that 2 multiplies root of 5. Okay, there's a multiplication. Okay. And just so you know, when you see 2 root 5 or 2 cube root 5 or anything like that, the whole number is multiplying the 5, okay? The root of 5, that answer of 5. So first of all, we're going to simplify. Simplify the following. And what we're going to do with that is simplify the following by writing as mixed radicals. Okay, so we call that simplifying, and you'll get the hang of it in a bit. So A, we're going to do a bunch of examples. So let's say you have the square root of 12. Okay, what we want to do is we want to try to break this apart. We're going to use this property up here, the idea up here. We're going to use that to simplify that, and maybe at the end you will have a whole number up front. Okay, so in this case we're talking about a square root. So remember that in order to cancel out a square root, you would want to write the prime factors to the power of 2. Okay, so why don't we do that here quickly? I know this one is fairly simple to do, but if you take 12, that is 4 times 3, and it breaks down into 2 times 2, right? 2 times 2 times 3. That's what that really breaks down to. So you can write that as square root of 2 squared times 3. And of course, this number, we know that 12 is not a perfect square. Why? Because we cannot write the prime factors that make up 12. It cannot be written in groups of 2. Right? But we do have one prime factor that has a power of 2 in front of it, which matches the index, so you'll be able to cancel it. So what we're going to do is we're going to split these apart, and we're going to say, hey, square root of 2 squared, right, times square root of 3, right? Because remember, this is A and this is B. We've split them apart like this using the multiplication property. Here we'll be able to cancel out the root, right? So this 2 here, I'll use a different color, right? That 2 goes with the power, and that there's nothing you can do with that. So that becomes what we call a mixed radical. Okay, this is a mixed radical because it has both a whole number and a root, right, combined. This would not be a mixed radical. This will be an entire radical. Okay, this is a mixed. So if you need to write this, right, rewrite it and simplify by writing it as a mixed radical, what you want to do is you want to go through this process to have as much as you can out of that root. That's what they're really trying to do, right? And we're still basing this on chapter 3. But I will show you that you will not have to necessarily do this. Often it's a lot simpler to do, right? Method 2, alternate method, right? If you wanted to look at it, you have square root of 12, and you know, okay, I know that that's 4 times 3, right? Like that, which I know is square root of 4 times square root of 3, and you know that the square root of 4 is 2, and square root of 3 cannot be done. So there you have it. Okay. By the way, square root of 3, is that rational or irrational? Well, the fact that you cannot take it out of the bracket, it would make it an irrational. It has to be a perfect square in this case for it to be a rational. Okay, so 12 as well, that'd be an irrational number. Okay. All right, let's keep going here. B, square root of 72. And I need to warn you, sometimes you'll think you'll be done, but you need to make sure that there's absolutely no way to get more out of that bracket. Okay, So let's just try this method here. Even though finding the prime factorization, some of you might prefer that, and I wouldn't see why not, that there's nothing wrong with it. But let's try this. Square root of 72. I know that's 9 times 8, right? If you have a bit of a number sense, you know that 9 is a perfect square and that's good. Okay? And then you would say, okay, well that's square root of 9 times square root of 8. And that is 3 square root of 8. And some of you might think, I'm done, right? It's like, not simplified yet, not completely simplified. Okay, it's not completely simplified, and you'll see why. So let's continue this journey. 3 root 8 can be written as 4 times 2. And that is going to be 3 times, so the 3 is multiplying this, and we're going to break down the 4 and the 2 into root 4 times root of 2. Okay, so I've taken this apart, but the 3, remember, it's almost like factoring, right? If you take out a GCF, it follows you. And so it's 3 times this. And we know that 4 is a perfect square, so this will just turn into 2, okay? So this is what you do. 3 times 2 times root of 2, okay? And what you do is you multiply the 2. You multiply 3 by 2 is 6, so that's 6 root 2. Just like that. We don't put a dot in between as our final answer. So this is simplified. Completely simplified. Okay. So you have that example. So let's say you wanted to break this down, right? So you'd rather do it this way: 236, 218, 3 and 6, 2 and 3, right? And then you wanted to write, right, alternate method. If you're more comfortable with this, you say, hey, square root of 72 is, I have 2 to the power of 3, right? Because I have 1, 2, 3 here, and 2 3s like that. Okay? And then you're going to break this down. So you're going to go square root. I'm going to take a 2 squared out and keep the square root of 2 because we have 3 2's multiplying each other, right? So I'm almost breaking this down into 3 pieces, right? So this 2 to the 3 are accounted for here, and I'm going to do one more root where it's 3 squared, like that, okay? And make sure, right, this is 2 2's and another 2, that's 3 2's, that's what I need, and there are, right, 2 3's as well, that's also accounted for. So this is also possible to do. We know that this gives me, if I cancel that out, I get 2 times, I can't do anything with the square root of, with a 2 here, and this cancels out there, so that's 3. So 2 times square root of 2 times 3. You multiply the whole numbers that you got out, and that's 6 root 2. And you arrive to the same conclusion there, same answer. Okay. C, square root of 99. How would you do that? And I will just use the method where I just slowly start to break down. I see that it's 9 times 11. Okay, square root of 9 times 11. And 9 is a perfect square. So I'm going to break this down into 9 times square root of 11. And I don't know if you remember, but 11 is a prime number, right? It's 2, 3, 5, 7, 11, 13. So you can't break it down anyways. A prime number is only divisible by 1 and itself. So this breaks down into square root of 9 is 3, and square root of 11, well, there's nothing you can do, and it's done. It's simplified there. D, square root of 20. And so I'm going to go square root of 4 times 5. Break that down into square root of 4 times square root of 5. 5 is also a prime number, so there's nothing you can do there anyways. 4 is a perfect square. We know that square root of 4 is just 2, and square root of 5 goes there. And there you have it. Okay. So I hope you get the gist of it. You can pause this, right, if it's going a little bit too fast, and just take your time. So we're going from entire to mixed, right? That's what we're essentially doing. Entire radical to mixed radical. Completely simplified, right? So you don't want, like if the 8 would not have been completely simplified, because you can still break that down, right? So we continued this here, we broke the 8 down and continued like that. Okay, let's continue backside here. E. How about 63? Square root of 63, and that would be, if you break that down, right, it's 9 times 7, which turns out to be square root of 9 times square root of 7. 7 is a prime, square root of 9 is just 3, and the 7 stays like that. Okay. How about EF here? Let's do one that's a little bit of a larger number, 180. Right? So what you do is, and I will do that with both methods. So that would be 9 times 20. 9 times 20, or it's really up to you how you want to do 3 times 60, right? If you wanted to do it that way, it's completely up to you. I'm going to go 9 times 20. Ultimately, we should all arrive to the same conclusion. Okay, that's square root of 9 times square root of 20. And that turns to be a 3 square root of 20. 20 can still be broken down further. Okay, so I'm going to continue here. 3 square root of 4 times 5. We did that earlier, actually, right? Which turns to be, don't forget about the whole number you took out, right? Square root of 2, square root of 5. This is all multiplying. Sorry, I made a mistake, right? I already jumped to the final answer. This is 4. So now we have 3 times 2 times square root of 5. And that is 6 root of 5. And if you're home and you want to check quickly, right, what you do is you take the square root of 180, you get 13.41 and so forth. You should get the same if you do this. So if you go 6 times square root of 5, this should not change on my calculator, right? See, I get the exact same answer. So that's how you know you're right if you're in a hurry and you want to check at home, right? Okay, so basically converting entire to mixed radical, right? Steps. I'll try to say break down number to find perfect squares, cubes, etc. This depends on index, right? Index is this little number that will be above here, and if it's 2, it's not written, right? we'll break, no, split, I will say, because I already split factors using multiplication property. Continue this process until you're left with you can't anymore, right? Until you can't go any further. Basically, that's what I would say there in terms of steps if you're reviewing this down the road, right? So let's try something that isn't always a square root. So f g here. What if you have cube root of 72? And I told you I was going to do this one, the square root of 180 in the alternate method, but I will do that with 72, okay? So with 72, and we have a cube root, right? I'll just make a note here. Index is 3, right? So we want groups of 3 basically. As much as possible. We know 72 isn't a perfect cube, right? But we'll try to get perfect cubes out of that number. So let's break it down here. 72, right? 2 times 36, 2 times 18, 2 times 9, 3 times 3. I just did it so that it's nice and organized, right? So you do have a group of 3 here, but you can't do anything here. Right, so this is good. So we'll be able to do that. So cube root of 72 is essentially cube root, don't forget the index, right? 2 to the power of 3 times 3 squared. Okay. And you break them apart, okay, that using the multiplication property, 2 to the 3 times cube root of 3 to the 2. And here you can cancel out. So that just leaves you with the 2. And you're left with cube root of 3 squared. You can't do anything here. This does not cancel out, right? Can't cancel here. Right? Can't cancel here, so we just leave it like that. Cube root of 9, because 3 squared is 3 times 3, and that's just that, okay? So this is the approach that you can take, but you won't, sometimes it's more time consuming, right? If you just knew, right, 9 times 8 would give you this, and you know that 8 is a perfect cube, right? Then it's faster, but this is, you're more than welcome to do this, but there won't always be room, so you might want to do it on Scrap. But if you're doing anything online and submitting, I want to see this work, okay, on the side. It's important to me. So let's try another one. H. Let's try. So I'm mixing up the index now, okay? So how about 4th root of 32? Okay, now I need perfect, right? N is 4 in a sense, right? So we wanna take groups of 4. We wanna make groups of 4. So if you wanna go 32, right? 2, 16, 2, 8, 2, 4, and 2, 2. So 1, 2, 3, 4, 5, right? But you're gonna focus on a group of 4, right? And write this like that. 2 to the 4 times just the 2 trailing, because you want to be able to match. You break them apart. This you're able to cancel out. So that just leaves you with 2 root 2. And this is always the same. It's always the same. But if you remember your perfect squares, perfect cubes, perfect fourths, and so forth, right? Too many fourths here. Then you can this might be faster to you. You might have been able to recognize, right, that 16, because 2 times 2 times 2 is 8 times 2 is 16. You could have just broken this down to 2 times 16, take the fourth root of 16. But I know that that's difficult sometimes, so just sticking to a method like this might be better for you, and that's completely fine. Okay, let's keep going. We're about to finish this lesson. So I'm going to grab another piece of paper. Make sure you write down the notes, all right? Don't just watch this because it's going to be hard to go back to later. Okay? Write each of the following, FF is for following, as entire radicals. And here we reverse the process in this case. Okay. So A, this is easier in my opinion. Okay. So let's say you have 2 square root of 7. Okay. And you want to end up with just a root and everything inside. So you're bringing what used to be outside, you're bringing it back in. Okay. So what you do is, if you bring the coefficient inside, a power of n needs to be applied. Okay, very important. So let's say you have a root n of b like this. If you want to bring the a inside, you have to do the following. Whatever the index is, you apply that to that coefficient that you're bringing in, and then just multiply it by whatever is already inside. But you can't just bring the 2 inside without applying an exponent to it, a power to it. Okay? So we're going to do this, right? So basically, when you bring the 2 in, the index is 2. So we say that 2 will have a power of 2 applied to it. And we multiply it by the 7 that's already inside. And that is really 4 times 7, which is square root of 28. Okay, so you went from a mixed to entire. Right, I hope that makes sense. It's reversing the process. And so let's say we have 7 square root of 3. Same idea. We are bringing the 7 inside, so we apply the index there, which is 2. And multiply that by 3, which is already inside. Do not apply it to whatever's inside. That doesn't need to be done. Okay, it's only when you're bringing it inside. Because remember, if you wanted to break these apart and then cancel the roots, you would end up with a 7, right? So go back to this. So this is consistent, okay? And that would be square root of 49 times 3. And that is 3 times 50 would be 150. So this is 147, right? 3 less than 150. And let's switch it up. The index here, 2 cube root of 4, let's say. So the index is 3 here. So to bring this 2 inside, we would go 2 to the power of 3. and we multiply that by 4. And that ends up being 2 to the power 3 is 8 times 4, and that is square root of 32. D, I don't know why we, okay, 2 root of 5, 3. Your index is 5 here, so we bring the 2 inside and apply the 5 to it as we do that, times 3. Oh, I forgot this, folks. Don't forget that. 2 to the 5, we just did that a little earlier. That's 32. Just think about it this way. 2 to the 8 is 8. 2 to the 3 is 8, sorry. Times another 2, that would be 4 2's, that's 16. Times another 2, that's 32. So it's 32 times 3. And that's fifth root of, you multiply, right? 3 times 2 is 6. 3 times 3 is 9. And there you have it. That's your final answer. I think you're grasping, you're probably understanding by now. And I just want to make a note here that I see common error. I see some students, if I say, hey, convert this mixed radical here into an entire, and this is what I see, but it's not the same. They'll just say, hey, I'll just put the 3 here and let's call that a day, right, Mr. Dirksen? It's like, nope, this 3 has to come inside and I will actually get a power. This is the correction. 3 root 7 is going to be 3 squared times 7, which is going to be 9 times 7, which is going to be 63, root of 63. That is the right thing to do, okay? Homework. Page 218. And we're going to do questions 4, 5, 9, 10 to 12. Do at least half. 14 to 18 and 20. And remember, yes, you're putting in a lot of effort, but it is important, especially chapters 3 and 4, okay? So put in the work, it's going to pay off. I'm not saying it's going to get a lot easier, but chapters 3 and 4 are by far the hardest, okay? That's all for today. Thank you so much, and then we'll resume on Thursday when we're all back together, okay?